Hello friends, I welcome you in lecture number 26 on graph theory. In this lecture also we are going to discuss about Warshall's algorithm. In lecture number 25 we have discussed Warshall's algorithm to obtain path matrix for a given graph. And here we are going to discuss Warshall's algorithm to find the shortest path between each pair of vertices of a given graph. So we will discuss this algorithm for shortest path with the help of example. So I have taken this example which was asked in GTU Summer 2021 exam. Here you can see we are given a graph in which weights are assigned to each edge. For example, the edge connecting 1 to 3 is assigned weight 3. Similarly, there is a weight 2 for this edge between 3 and 4. So this is the graph in which each edge is assigned a weight, or we can say that it is the length of the edge. So whenever we have this type of weights assigned on the edges of a graph, we can write down the weight matrix for the graph. Now here the question is find the shortest path between each pair of vertices for a given graph. For example, we can see here that if I want to find out the path from vertex 1 to vertex 4, then you can see this is one path. I will go from 1 to 4 and so I have this path from 1 to 4, and if I consider the weight assigned to this edge, then it is 8. Now if I consider this path, I can go from 1 to 4 along this path also. First I will go from 1 to 3 and then I will go from 3 to 4. So here if I take the sum of these weights from 1 to 3, I have weight equal to 3, and from 3 to 2 I have weight equal to 3 to 4 I have weight equal to 2. So this is equal to 5. So the path for which this sum of weights is minimum is called the shortest path between given pair of vertices. Here for these two vertices from 1 to 4 we have seen two paths. Similarly, we can go along this path also. I can go from 1 to 2, then from 2 to 3, and then from 3 to 4. So along this path the weights are from 1 to 2 weight is 5, then from 2 to 3 weight is 7, from 3 to 4 weight is 2. So we can see this is 14. So we have 3 paths from vertex 1 to vertex 4, and the path for which this sum of weights is minimum is called the shortest path between those two vertices. Now it is not comfortable to find out the shortest path between each pair of vertices by trial and error in this way. So for that, Warshall has given one algorithm. Using that algorithm we can obtain the matrix which will give us the length of the shortest path between vertices. We will obtain this type of matrix that we will denote by capital Q, and the entries of this matrix will be the lengths of the shortest path between each pair of vertices. So how to obtain this matrix, that we will denote by capital Q, and entries of that matrix will be the lengths of shortest path between each pair of vertices. For example, if I have 7 here, then the length of the shortest path from 2 to 3 is 7, or whatever path we have obtained from 2 to 3, that path is shortest in the sense that the sum of weights assigned to edges along this path is minimum. So to obtain this matrix Q, first we have to write down the matrix which is giving us the weights which are assigned to every edge of given graph. That matrix we will denote by capital W, and we will write that matrix in this way. The first step is write down the matrix in which entries are weights assigned to edges between given vertices. For example, I can write weight matrix here. So to write down the weight matrix, I will write vertices 1, 2, 3, 4 for rows of the matrix, and similarly for columns of the matrix I will write 1, 2, 3 and 4, and entries of this matrix are nothing but weights. For example, for this first entry, if I consider 1 to 1, then there is no edge which is starting at 1 and ending at 1, that is, there is no loop at 1. So there is no loop at 1, therefore weight is 0. Similarly, from 1 to 2, we can see this is an edge from 1 to 2 and weight assigned is 5, so here I will write 5. From 1 to 3, weight is 3. From 1 to 4, we have 8. Then from 2 to 1, there is no edge between 2 and 1, so here I will write 0. There is no loop at 2 also, so I will write 0. Then from here I have made a mistake. I have to see for this 2 is the vertex, this 2 is the weight. So from 2 to 1 I have 6 here. From 2 to 2 there is no edge. From 2 to 3 we have 7. From 2 to 4 there is no edge, so here I write 0. Then from 3 to 1 there is no edge between 3 and 1. From 3 to 2 also there is no edge, this edge is from 2 to 3. From 3 to 3 also there is no edge or there is no loop at vertex 3. From 3 to 4 we have edge and weight assigned is 2. Then from 4 to 1 we have edge which is having 6 weight. From 4 to 2 there is no edge. From 4 to 3 also there is no edge, and from 4 to 4 also there is no edge. So first step is to write down the matrix which indicates the weights assigned from one vertex to another vertex, and if there is no edge between two vertices we will write 0. After that we have to obtain a sequence of matrices starting with Q0 and Q1, Q2 and so on Qn, where this n is the number of vertices. Here we have 4 vertices, therefore we have to obtain a sequence starting with Q0 and we have to go up to Q4. So we have to obtain these 5 matrices starting with Q0 and ending with Q4. So how to obtain these 4 matrices? Q0 we will call as initial matrix and Q4 will be called as final matrix, and this Q4 is the required matrix whose entries are nothing but lengths of the shortest path between each pair of vertices. So our aim is to reach up to Q4 starting with Q0 and using previous matrix to write down succeeding matrix. Now first, how to write down Q0? So the initial matrix Q0 is nothing but the matrix W which we have written here. To write down Q0 we will use this weight matrix W, and we will write down all the non-zero entries as it is of W in Q0 also, but the entries which are 0 will be replaced by infinity or a very large number. So replace 0 by infinity in W and keep all other entries as it is, and we will be able to write down Q0. So that I have written here. First I have written W. Let me check this W also. Here we have 0538, then 6070, 0538, 6070, and here 2 and 6 other entries are 0. So this is correct. And using this W we have written initial matrix. You can see this 1, 2, 3, 4, 5, 6 zeros are replaced by 1, 2, 3, 4, 5, 6, and these two are also. So they are replaced by infinity. We can check row wise. Here 0, so I replace 0 by infinity. Then 5, 3, 8 as it is. For second row 6, 0 is replaced by infinity, 7 and infinity. Then there are 3 zeros, so 3 infinity and 2, and 6 and 3 times infinity. So this is the initial matrix. Now how to write down Q1, that is next matrix in our sequence. So for that first we write down these vertices for rows and columns. 1, 2, 3, 4, and here also I will require 1, 2, 3 and 4. Now whenever we are writing Q1, we will copy this first row and the first column of Q0. Okay, remember this. If I am writing Q1, then first row and first column of Q0, Q1 is same as Q0. Whenever I will write Q2, then second row and second column of Q2 will be same as that of Q1. When I will write Q3, third row and third column of Q3 will be same as those of Q2. So remember this algorithm in this way. So first I am writing this first row and first column as it is from Q0. First row is infinity and 5, 3, 8. So here I am writing infinity, 5, 3 and 8, first row of Q0. Here I have 6 infinity and 6, 6 infinity and 6. Now for other entries we have to use this formula which was given by Warshall. Suppose I am interested in the ijth entry of Q1. ijth entry of Q1. How to write down ijth entry of Q1? So that is equal to minimum of two numbers. First number is ijth entry of Q0, comma I. Here I have 1. I am writing Q1, so I will write Q0 I1. That is I1 entry of Q0 plus 1j entry of Q0. I have to write down ijth entry of Q0, and here I am inserting 1 in between these two. I am inserting 1, so I have to write I1th entry of Q0 and 1jth entry of Q0 and their sum. So here I will have two numbers, and minimum of those two numbers will give me ijth entry of Q1. For example, if I am interested in this entry, say Q1 of 2, 2. So I and j are 2, 2 here. So let me replace I and j by 2. Here I am writing 2, 2. I and j both are equal to 2. So here I will write 2, 2. Then I is 2, j is 2. So for that I have to search in Q0 2th entry of Q0, that is entry at this position 2, that is infinity. I am considering 2th entry of Q0, that is infinity, or we can write here also minimum of infinity. Then 1th entry of Q0 and 2th entry of Q0. 1th entry means entry at this place, it is 6, so here I will write 6, plus 2th entry of Q0. 2th entry of Q0 means 5. Entry in first row and second column is 2th entry of Q0, that is 5. So let me write 5 here. Now I have to decide minimum of infinity and 11, so that is obviously 11. So this entry is 11. So in this way I have to use this formula for every entry of Q1. After that I have to write Q1 of 2, 3. So what I will do here, now I will write 2, 3, that is my j is 3 now. So here also I have to write 2, 3. Here j is 3, so here I have to write 3. Now I have to write for 2, 3. This is already 6. 2, 1 is 6. So I will search in Q0 for entry in second row and third column. Entry in second row and third column is 7. So this is 7. Here I have to write entry in first row and third column of Q0. First row and third column of Q0 is 3. So that I will write here. And now I have to decide minimum of 7 and 9, that is 7. So I will write 7 here. So every time I am using entries of Q0 to write down entries of Q1. Suppose we write further entries using this formula. Let me remove this. So every time you have to use this formula, and be careful, if you are writing even a single entry wrong, then you will get wrong answer. Now I have reached up to entry in second row and fourth column of Q1. So now I am writing Q1 of 2, 4. This is equal to minimum of, I am using Q0 of 2, 4, and because I am writing entries of Q1 between 2 and 4, I will insert 1. So here I will write Q0 of 2, 1 plus Q0 of 1, 4. This is very easy to remember. Here I am writing 2, 4th entry of Q1, therefore here I am writing 2, 4th entry of Q0, and because I am writing 1, I will insert 1 between these 2 and 4. That is, first I will write Q0 of 2, 1 and then Q0 of 1, 4. And this you can write from Q0. For this I have to look at second row and fourth column of Q0. This is second row, fourth column is infinity. So this is 2, 4th entry of Q0, that I will write here, it is infinity. For this I have to write entry in second row and first column of Q0. Second row and first column of Q0, that is 6. So that I will write here, plus Q0 of 1, 4. So first row and fourth column, that is entry is 8. So that I am writing here, and this is going to be 14, and minimum of 14 and infinity is 14. Therefore I have written 14 here. I am writing 14 here. So this process you have to repeat for each and every entry. Suppose I am interested for Q1 of 3, 2. So now I have to change here let me write here q1 of 3 2. So q0 as it is, here I will write 3 2, and because I am writing for q1, you can understand in this way. I will first write for 3 to 1, so 3 to 1, and from 1 to 2, and this I will obtain from q0. I have to look for 3 2, q0 3 2, this is 3 and 2, q0 of 3 2 is infinite, so that I will write here. Then q0 of 3 1, 3 and 1, that is also infinite, and don't worry about this because this is going to be infinite, so here I will write infinite. So in this way I have written q1 matrix here. We can verify these calculations with the matrix which I have written, infinity 5 3 8. So you can see this is infinity 5 3 8. Here I have 6 11 7 14. So this is 6 11 7 14, then infinity and infinity. You can verify other entries also. Now using q1 I have to write q2, and I have to go up to q4 because I have 4 vertices here. So I have written all the matrices by doing this type of calculations, but we can write few entries of q2 also. Suppose we write in parallel here. Here I will write for q2. So let me write here 1 2 3 and 4, then 1 2 3 and 4 here. Now remember, if I am writing q2, I will copy second row and second column of q1 in q2. This I have to write as it is in q2 because I am writing matrix q2. So this suffix, because I have 2 here in the suffix of q, I will write second row and second column as it is. So let me write first this 6 11 7 and 14, and the second column is 5 11 infinity and 11, and rest of the entries will be written by using that formula. So if I am interested in this entry q2 of 1 1, so because I am writing q2, I will use entries of q1. So first I have to write q1 of 1 1, and here because I am writing for q2, the intermediate vertex I will use is 2. So now in this part, first I will go from 1 to 2, q1 of 1 to 2 plus q1 of 2 to 1. Remember in this way. Here I am writing q2 1 1, so here I will write q1 1 1, and here I am interested in 2 entries. So those 2 entries are, because we are writing q2 here, we will go from 1 to 2 and from 2 to 1. Okay, remember in this way. Here I have 1 1, and I am going from 1 to 2 and then from 2 to 1. If I am writing q3 of 1 1, then here my vertex will be 3, so I will use 1 to 3 and 3 to 1. So you have to remember in this way. Now we can see here from q1 of 1 1, that is infinity, q1 of 1 2 is 5 plus q1 of 2 1, q1 of 2 1 is 6, 5 plus 6 is 11, and another number is infinity, so minimum is 11, therefore this entry is 11. Now suppose we are interested in q2 of 1 3, so what will be the change here? Now this number is 3, q2 of 1 3, so here I write Q1 of 1 3, then I will go from 1 to 2 that I have written here, and from 2 to 3. So here I will write 2 to 3, and Q1 of 1 3, Q1 of 1 3 is 3 now. Q1 of 1 2 is already written, it is 5, and Q1 of 2 3, that is 2 and 3, which is 7. So this is going to be 12, and here we have 3, therefore this entry is 3. Similarly, I can write for Q2 of 1 4. So here I write 1 4, then 1 to 2, and from 2 to 4. So every time I have to repeat this for every entry. Q1 of 1 4, that is 8 here. Q1 of 1 2, that is 5, plus Q1 of 2 4, 2 and 4, that is 14. So this entry is 8, and I have written all the entries of Q2 by using this formula. We can just verify these entries which we have obtained: 11 5 3 and 8. So those are 11 5 3 and 8, and you can obtain or verify all these entries by doing calculations which I have done here. Now this we have to repeat for Q3. If I am writing Q3, then I have to repeat third row and third column of Q2 as it is. In writing Q3, here I am writing Q3, few entries of Q3 I am writing. So what I will do, I will repeat third row and third column of Q2. So this is third row, third column is 3 7 infinity 9, 3 7 infinity and 9. Now suppose I am interested in these 3 entries, then because I am writing Q3, suppose I am writing this entry, then I have to write 4 comma 1 here. Now you can guess this is minimum of, because we are writing Q3, here we will use Q2, previous matrix, Q2 4 1, and because here I have suffix 3, intermediate number is 3, so now I will go from 4 to 3 first, and then from 3 to 1, and we have these entries of Q2, minimum of Q2 4 1. Q2 4 1 is 6 from this matrix. What is Q2 4 3? Q2 4 3 is 9 plus Q2 3 1. Q2 3 1 is infinity. So this is going to be 6, because infinity plus 9 is infinity. So this entry is 6. Similarly, we can write for Q3 4 2. So in that case, I have to write Q3 4 2 here also, then from 4 to 3 and from 3 to 2. Now what is Q2 4 2? Q2 4 2 is 11. So this number is 11. Q2 4 2. This is Q2 4 2 11. Q2 4 3 is already written, it is 9. Then Q2 3 2. So third row and second column, it is infinity. Infinity plus 9 is infinity. So this is 11. And we can write Q3 4 4 similarly. Now I am not writing, I hope this is enough. We can verify these entries 6 and 11. In fourth row we can see this is 6 and 11. And similarly, using entries of Q3, we can write Q4. And what we will do in Q4, we will keep fourth row and fourth column of Q3 as it is, and remaining entries will be obtained by using that formula of Warshall's algorithm. So after using that formula, I obtain this Q4, and because I have 4 vertices, this is my required matrix whose entries are lengths of the shortest path between vertices of a given graph. If I am considering this entry 7, then 7 is the length of the shortest path from 2 to 3. We can check in our graph from 2 to 3. I have written this paths also. From 2 to 3 I have this path. Okay, this 2 3 means path is going from vertex 2 to vertex 3. So that I have, if you check the graph of given question from 2 to 3, we can see this is the graph, this is the path from 2 to 3 having only one edge and its weight is 7 or length is 7, and we can have another paths also from 2 to 3. For example, if I go along this path from 2 to 1 and from 1 to 3, then along this path length will be 6 plus 3, that is 9, but shortest path is from 2 to 3. So that I have mentioned here. Entries of this matrix are lengths of the shortest path between vertices, and these entries are nothing but paths, shortest paths between vertices. If I consider this entry 4 1 3 4, then this is the shortest path from vertex 4 to itself, and its length is 11. Okay, we can see in the graph also. If I go along this path 4 1 3 4, let's see here, we are going along this path 4 1 3 4 and length of that path is 11. For example, if I go from 4 to 1, from 4 to 1 weight is 6, from 1 to 3 it is 3, and from 3 to 4 it is 2. So you can see length of this path is 11, and we can see we have this path also from 4 to 1 and from 1 to 8. We can observe this path also from 4 to 1 and 1 to 8, but here length is 14. So this is the shortest path from 4 to itself, and 11 is the length of that shortest path. So whatever matrix I have obtained, this Q4, that I will denote by capital Q, and entries of Q are nothing but lengths of the shortest path between the vertices of given graph, and entries of this matrix are shortest paths between vertices. These entries are nothing but shortest paths between the vertices, and these corresponding entries are nothing but lengths of those shortest paths. So if you are asked to write down the shortest path between each pair of vertices, then after finding this final matrix, you can write this matrix using these lengths, and these entries are itself shortest paths between vertices. If they ask you to find out the lengths of the shortest path between vertices, then you need not write this matrix, but in this question they have asked to find the shortest path between each pair of vertices. Therefore we have to mention the shortest path for which lengths are entries of this matrix Q. So in this way we can use Warshall's algorithm to find out the lengths of shortest path between vertices or shortest paths between vertices. We can quickly summarize whatever we have understood. First we have to write down the matrix in which the entries are weights assigned to edges of given graph. After that we have to find a sequence of matrices. If there are n vertices in the graph, then we have to obtain q0, q1 up to qn, and qn will be required final matrix. To write down q0, that is initial matrix, we will write down entries of w as it is, and the entries of w which are 0 will be replaced by infinity. Then to write down entries of q1, we will use entries of q0. To write down entries of q2, we will use entries of q1, and for that we will remember this formula. Suppose I am interested in writing the ijth entry of matrix qk, then it is minimum of ijth entry of previous matrix, that is qk minus 1, and because I am writing for qk, here I will go from I to k and from k to j, that is ikth entry of qk minus 1 plus kjth entry of qk minus 1, and this I will repeat for k equal to 1, 2, 3 up to n. This is the main formula for this Warshall's algorithm for shortest path problem. So I hope I have explained this Warshall's algorithm so that you can understand it. If you have any doubts, you can ask in comment sections. Your suggestions or feedback is welcome for further improvement. Thanks for watching.